My name is Mr. Schweitzer, and I'm looking to have a little video here on how you measure liquids. Now, when you measure a liquid, a couple things that kind of matter is one, how big a sample you have, a real big one or a real small one. That's going to determine the device you're going to use to measure it. And also, two, how much accuracy would you like when measuring these things as well. Generally speaking, well, not always, the bigger the sample, the less accurate it's going to be. So for, let's say, larger things, we use what's called a beaker. Now, a beaker is your standard just cup. It holds liquids. The numberings here are very vague. We would never want to use a beaker to measure something precisely in a lab. If a lab says, I want 50 milliliters of liquid, I would not use a beaker for that purpose. I would use something like, let's say, a graduated cylinder. We'll get to in a moment. But this thing says we're going to boil, some water, something that's not very, actually is not very much of a concern. Okay, boil 300 milliliters of water. Maybe we just fill up here and boil 300 milliliters of water. Otherwise, we would want to use something a little more accurate. So beakers come in various sizes, not very accurate. Next up here on my list is what's called an Erlenmeyer flask. Now, an Erlenmeyer flask is just a specialized beaker. It's got a little bit of a narrower head on it. Again, just used to carry or hold a liquid during a chemical reaction. The narrower head shields it from the outer environment a little better, and we use it for a couple of specific uses, but not very often. So an Erlenmeyer flask, often referred to as an E-flask. Something you may not see a lot of, just a narrower head on it. The next thing on our list is a graduated cylinder. We use them all the time in lab. They come in various sizes. I have a larger one here. Although they can get bigger, down to a smaller one, and of course they can get smaller yet. You'll see, first of all, it's measuring smaller volumes. You've got a lot of lines here, so in class we'll learn more about how you actually do this, but either way, it's got a much more accurate measurement. Something we use very common. A few safety things on here. One, the bottom is not circular, so it cannot roll off a table. If it's plastic, it doesn't have one of these, but a glass one will have a little lip here. It's not used for measuring. It's meant where it falls over, it's not going to break the end. So this is called a graduated cylinder. Graduated simply means that there are lines on it, multiple lines that you can use to measure multiple different volumes. The term volumetric, which is right here, means this device has only measured one volume. That's all it can do. It can only measure one volume. This can measure many volumes, so it's graduated. Volumetric, only one volume. All of these things so far would be graduated. They can all do multiple volumes. When you're measuring a graduated cylinder, because it's a narrow cylinder, one thing that tends to play a role is what's called a meniscus, the top or the bottom, depending on whether your liquid attracts to the edges or repels from the edges. It could form a lower meniscus. If it attracts to it, it'll form a little cup or meniscus. Or if it repels from the sides, it would form a little upside down W or horseshoe type looking thing, also referred to as a meniscus. Whenever we have that, we measure at the most extreme top or the most extreme bottom of the actual dip. Most time we're using water, and that will form a little like U shape, and we measure the bottom of that meniscus, just so everyone's consistent. That's how they do it. Wider containers, it's just you're just not. You might see the lip at the edge, but we're just use the middle, which is flat. Okay, graduated cylinders. Other than that, they're pretty straightforward to use. If I want to get to an even smaller device, I have what's called, well, I guess the next one on my list would be a volumetric flask. Now again, volumetric, first time we're using that term, would be a single device, a single volume substance. This is an example of a volumetric flask. Now this one is only designed to measure one volume. That is 100, or in this case 1,000 milliliters. You'd fill it up and simply fill it to the lines, hard to see in the video, but there's only one line here, and I would use my meniscus, and I would line the meniscus up exactly with this line here. Okay, volumetric flask. Multiple sizes of those already as well, big, all down to small, whatever size you would want, you would have to get that size. Coming down here, we have two more things: graduated pipette and a volumetric pipette. So a pipette is going to be used to measure smaller liquids. A graduated would be a device that can do more than one volume, but a volumetric could only do one volume. So a volumetric pipette, and we'll have a video on how to actually use one, is essentially it's a straw. You would draw air up through the top, and you would then just dispense a certain amount. Let's say you want to do 1 milliliter. You could dispense from 1 to 2. Or based on the lines, you could dispense more. Okay? But it's got many lines, and we'll use these once or twice through the year in regular chemistry. I would say in more advanced or honors and AP, we might use them more often. In college, use them a lot. They can get big, they can get tiny, or they just they're a little more mechanical. Where they have, you could take even smaller, small microliters amounts of volumes. A volumetric pipette, again, this is only designed to measure one volume, 25 milliliters. That line is located right here. Hard to see. But again, it's a straw which fill this little vessel up in the middle and up to this one line. That would be 25 milliliters, and that is it. So as far as measuring liquids, that's pretty much it. These are some of the devices that we use to draw the air up into into the straw type substance device here, and we'll talk more about that later.